Hello and welcome to 6.3. This lesson is elimination using addition and subtraction. Previous objective was to solve systems of equations by using substitution, and today we are going to solve systems of equation using elimination with addition and subtraction. Again, the whole point of chapter 6 is to talk about two lines that intersect. And if they intersect, we're trying to find that point on the graph of where they intersect. If it's infinite solutions, that means it's the exact same line. And if it's no solution, that means that they will never intersect and they are parallel lines. Vocab is elimination. And again, I don't want you to find the definition of elimination. What I want you to do is write the steps to solve using the elimination process. Let's get started. All right, example number 1, using elimination using addition. So we have two equations here, and they're both pretty yucky. Neither one of them is set equal to x or y, so we can't really substitute. We could, but it would be kind of yucky. So there's the next technique, it's called elimination. When you look at two lines and you see that you have two variables that are exactly the same, then we can use the elimination method. So since the coefficients of the x terms, -3 and 3, are additive inverses, you can eliminate the x terms by adding the equations. So all you're doing is you're setting it up like an addition problem. When you take -3 plus 3, it eliminates. So you're only left with what's left. In this case is -2y equals 30, so y equals -15. Now, same rules apply. You're going to take that -15, plug it into either equation, and you are going to solve for x. So we're going to plug it into the first equation, and when I solve it, I get x to equal -24. So the point where those two graphs intersect is at -24 and -15. So let's do one together. I look at this equation and I have a 5x and a 3x, but I have a y and a y, so 1 and 1. A positive and a negative, if I add these two together, they will eliminate the y's. 5 plus 3 is 8x. 1 plus -1 is 0, so I'm left with 8x equals 16, so x equals 2. Now the same rules apply, just like substitution. We need to figure out what our y value is. You can plug it into either equation. 5 times 2 plus y equals 9. So 10 plus y equals 9. Subtract the 10 from both sides, and we get y to equal -1. So where do these two graphs intersect? They intersect at 2, -1. All right, I apologize, my slate is a little glitchy today, but I want you to try example number 1, use elimination to solve the systems of equations. Notice how you have a -5 and a +5, so when I add these together, I will eliminate the y's. You solve for x, plug it back in, and solve for y. Multiple choice on the Google form. All right, let's move on to example number 2. Example number 2, basically the exact same thing. They're going to give you some word sentences that you need to translate into equations. So 4 times one number minus 3 times another number is 12. So we have 4x minus 3y is 12. The second equation is 2 times the first number added to 3 times the second number is 6. So we figure out the second equation. So now I have two equations. Example number 2 is simply just writing out the equations and solving it just like you did in example number 1, using elimination to solve. We have a -3 and a +3, so we're going to add them together and eliminate those y's. We get 6x equals 18, x equals 3. Plug it back in. Substitute 3 in for x, either equation works, and you're going to solve for y. Plugged it in the first equation, and we get y to equal 0. So your numbers are 3 and 0. All right, so this is the open-ended question on the Google form. I want you to try one. So 4 times one number, that would be x, added to another number, that would be y, is negative 10. 3 times the first number, that would be your x, minus the second number, y, is equal to negative 11. So set this up, use elimination, and find the two numbers. All right, example number 3 is no different. We are now using subtraction. So this means when I have two that are exactly the same, in order to eliminate, I am going to have to subtract. So 4x minus 4x eliminates. 2 minus a negative 3y ends up being 5y. And here I get 16, 2, 3, and 46. No, that's not right. 16, 3, 46, yeah. 2 minus this 5y. Oh, I'm subtracting. I apologize. 28 minus 18 equals 10. Divide both sides by 5. Trying to add them together. What am I thinking? Y equals 2. Plug it back into either equation. I'll just do the top one. 4x plus 2 times 2 is 4 equals 28. Subtract the 4 and divide by 4. So 4x equals 24. X equals 6. So where do these 2 points intersect? At 6, 2. All right, let's try another one. If you want to pause the video, it is a checkpoint if you want to try this one on your own. We have 9x and x, but we have a negative 2y and a negative 2y. Well, in order to eliminate these, I'm going to have to subtract them. 9x minus 1x is 8x. And negative 2 plus 2 would eliminate my y's. And 30 minus 14 is 16. Divide both sides by 8, and you get x to equal 2. Plug it back in. I'm going to use the second equation. 2 minus 2y equals 14. Subtract 2 from both sides. Negative 2y equals 12, so y equals negative 6. So where do these two lines intersect? At 2, negative 6. All right, it looks like that is it for the video. You have a multiple choice in there. You have an open-ended. It is very similar to the substitution in the sense that we are finding the one point at which two lines intersect. Elimination, it comes in handy when you look at your equations and you have two variables that are set equal to each other. 2x, 2x, 4x, negative 4x. We can add or subtract using elimination to find what our variable equals and then substitute it back in and find what our other variable equals. All right, if you have any questions, make sure to answer them in the Google form, and we will see you tomorrow.